And I don't know if you've probably seen some of the maps, but we're standing to the northwest of Water Conservation Area 1, also known as the Loxahatchee National Wildlife Refuge. And this is Stormwater Treatment Area 1, and we're standing just at the flowway that comes straight across. It's roughly a 3.5 mile flowway that takes the agricultural water from, it takes in the agricultural water that comes in roughly at around 150 parts per billion of phosphorus. And phosphorus is what we're really working to remove because it's the limiting nutrient in the Everglades. So it comes in at around 150 and flows across and discharges here at around 20. The agricultural community, the EAA, has done a great job of removing about 50% of the load of phosphorus that used to come. And the STAs then remove about 80%, depending on what year you look at, 80 to 85% more. The goal is to get down to a 13 parts per billion discharge concentration measured at an annual flow weighted mean. 13 is a very low number. We don't know of anyone that's ever achieved it anywhere in the world or attempted it. So we're trying something new, and we're close at around 15 to 19 to 20, depending on what year we look at, with no cigar. We need to be consistently below 13. So to do that, we're going to expand this STA by building another 4,500 acres here in this sort of mustard color, and then another area down here. And we're going to build a surge tank, basically a reservoir, up to the north. This is part of an expansion program that, will expand a number of the STAs, but this one will grow by quite a bit. It's 7,000 acres now, and we're going to add another 6,500 acres to try and get us down below 13. Thanks. So what you see out here, this brown vegetation that you see is called SAV, or submerged aquatic vegetation. Here's a bag of it. You want to just look. It's not pretty, but it takes up the phosphorus. When the phosphorus concentrations are lower, it binds it with calcium, and then it eventually dies, decays, and goes to the bottom. That mix of calcium and phosphorus creates a fairly stable bottom sediment that doesn't flux back up into the water, the phosphorus that we just removed. But these are very dynamic. There's a constant uptake by plants, by algae, by fish, invertebrates. Then they die and they go to the bottom. Then they decay and the phosphorus goes back up. So there's this very dynamic cycling of phosphorus in these wetlands. And I was telling the last group, we seem to reach sort of a plateau toward the back end where this dynamic equilibrium hits around 15 to 20 parts per billion. And it's hard to get below that. So that's why we're expanding them, and we're also studying all the different mechanisms right now to see if there are things we can do with the wildlife or the birds or the snails. We have snails that eat huge amounts of vegetation. They're from South America. We're trying to figure out what little thing can we do to get us down another 5, 6, 7 parts per billion so we hit the target. If you look out over this area, the SAV is all this brown vegetation that just comes to the surface, but it's basically submerged. Then this area out, you can see a line of cattails and bulrush, and we create compartments in this flowway so that if a hurricane comes through and tears up this submerged aquatic vegetation with waves and wind, it'll be caught kind of on those areas and won't flush all the way out and down into the discharge canal and into the pump station. It's hard to see it, but it's way down in that direction, but it's 5.5 miles away is the discharge from this STA. There's a small white building on the horizon. It's actually a big building, but it's far away. This is 7,000 acres, and it is large, and so it starts out in the front end where the highest concentrations are with cattails and bulrush. That takes up the phosphorus. Then it moves into this portion, which is primarily submerged aquatic vegetation. The STAs have lots and lots of wildlife. They're used for recreation, bird watching. Audubon, those folks come out. On different days, the hunters come out, hunt ducks, and then this time of year, we actually have alligator hunting on Friday and Saturday nights, so if you all want to be involved in an alligator hunt, you can do that. It's very exciting. You catch the alligator, drag them in, and you hit it with a bang stick, and you can sell the meat and the skin. But people, I haven't done it, but I've heard it. It sounds exciting just by listening. So the STAs are widely used for recreation and other purposes, and they serve a very important purpose. We accumulate about 1 centimeter of sediment on average a year in the STAs, and so some folks have asked, well, what happens, when that keeps building up? And we know that in, say, 30 years, at 1 centimeter a year, that's about a foot of accumulated material. These are part of the flood protection system. The levees are only so high, we have discussed the option in 30 years or 20 years that we might need to go in and actually excavate a foot of material from the stormwater treatment areas, which would be very expensive. That'd be about $2.5 billion to do that. We've spent roughly $1 billion building the STAs that we have. There's roughly 57,000 acres of treatment wetlands, and we are planning to spend another $880 million to expand them further. So it's an expensive endeavor. In the back is Nate Ralph. He's one of the scientists that manages the vegetation. So it's a constant sort of manicuring and managing of exotic vegetation that we don't want and the desirable vegetation that we want to encourage. So Nate and his associates are flying over in helicopters. They flew over earlier today to look at all the vegetation, whether or not we have spots that need planting or need spraying with herbicides to control maybe the cattail moving into these areas. So it's a very highly managed system. We monitor it on a weekly basis. We report to EPA and the Department of Environmental Protection on a monthly basis. So it's a very actively managed system. We watch the stages from a control room in West Palm Beach, and these are probably the most highly managed treatment wetlands in the world.